So with the histogram, you'd need an x and a y-axis.
Mm-hmm.
And then going up would be going from 0 to 70 on the y-axis.
Nope. You need the height. So the frequency is the area.
Yeah.
The height is the frequency density.
Okay.
Let me go back.
It's frequency over class width.
Yep. Well, I didn't know that was there. Yeah, base times height is area. Class width times frequency density equals frequency. And that's how we do these rectangles.
So which one's class width?
Class width is upper bound minus lower bound.
Which is 5.
Yep.
Okay. So all of them are 5. This is the class width is 5.
No.
Oh wait, no. So 3 of them are 5, one of them's 10 and the other one's 20.
Yeah.
So would you do 55 divided by 5?
Yep.
Which gives you 11.
Yep.
And then you do 39 divided by 5, which is 7.8.
Okay.
And then the other one's 13.6. And then 3.2. Another one is 0.3.
Looks good. Okay. And so how would we draw these?
So it would be, y-axis would be 0 to 14. Would that be right?
Yep. And we could... No. Wait, how do you get 14? Yeah. Sorry, let's say 14.
Yeah.
10. 6, 4, 2. And then this one, I'll just put in a break.
Yep.
And so that's 25 up to 80.
Yep.
30, 35, 40, 45, 50, 55, 60, 70, 75. It's the best I can do. So how would you draw the first one?
So it would stretch across from 25 to 30. So it'd be the first bar, and then it'd go up to 11. So between 10 and 12.
That's it. Yeah. You would do the same for all of those, and there's no gaps between them.
Yeah.
So this one, that's 7.8. It'd be like that. There's no gap between them.
Yeah.
Very last one is 50 to 80, 75, 70, 65, 60, 55, 50, and that goes up only 0.3. So this is just a little sketch I've done. You'd need to do a proper thing on axes. And how does this line work that they did in the middle?
It's from midpoint to midpoint.
Yeah, that's it. Okay. Let's take a look at this.
Okay. Well, you could use a histogram because you've already got it as a frequency table, don't you? Which makes it easier.
Yes. So give a reason. Because it's grouped data.
Yeah.
It's grouped data. Yeah, it's grouped frequency data, something like that. Grouped data. Any idea what B is about?
No.
So in the same way that like base times, I'll call it width, width times height equals area, class width times frequency density equals frequency. You can see how they're matching up with each other. With class width, height of the bars are the frequency density, and you can see areas matching up with frequency. Basically, it is area is proportional to frequency.
Yeah.
And that's all you have to say. The area of the bars is proportional to the frequency of the groups. Area is proportional to frequency.
Okay.
Okay. Okay, how about C?
Yeah. So you need to do 3.2 times 2.
Let me see. So, this is, yeah.
Which gives you 6.4.
So that gives you 6.4.
Yeah.
And so 6.4 is proportional to the 8.
Yeah.
So let's say 6.4 times by something gives you 8. And so what is that something?
Divide by 6.4 on both sides.
Mm-hmm.
Which is 1.25.
Sorry, other way around. 8 equals 6.4 times something.
Okay.
No, I did it again. 6.4 is equal to 8k. Yeah.
So you'd get 0.8.
Yeah. So k is 0.8. And how about D?
So it's 48 the area under the histogram.
Total area under the histogram, yep. All the rectangles added up.
So would you need to divide by 8? Or 0. Wait, no. Yeah, 8.
0.8.
0.8.
Yeah. 1 day is 0.8, and so 48.
60.
60 days. 48 over 0.8. 60 days. Let's see. 60 days, yep. So the area of the bar is 6.4. 6.4 divided by 8. Temperature is continuous and the data was given. Oh, so I need to say that it's not just grouped data, it's grouped continuous data.
Okay.
Not discrete. That's why you have that in the group. Yeah. The area of the bar is proportional to the frequency. All right. Unless you have any questions. Let's see this one. Yeah, let's try it.
So would you get all the frequency densities first?
You mean all the frequencies, is it?
Well, no, 'cause in the graph it says frequency density would be 4.4 for 56 to 58.
Oh, I see what you're saying. Okay. So longer than 56 seconds. How do you go about that?
So would you take the numbers from frequency density or not?
So what would those be?
4.4 and 1.
Is it 4.5?
I think it's 4.5, 4.4.
Oh, I see what you're saying. All right, I'm understanding. Yeah. Okay, go on.
And then would you add them?
No. So area is proportional to frequency, and so base times height area, you would do basically base times height, and that would be the number of girls, the frequency.
Oh, so you do 1 times... Would you do 58 minus 50?
No. What's the area of the...
Oh wait, I think I know. It's that area, so it's from 62 minus 58.
Yep.
Which is 4, so 4 times 1 is 4, so 4 there.
Yeah. So that represents 4 girls.
Yeah, and the other one would be 2 times 4.4.
I think it's 4.5.
Oh yeah, it is. 2 times 4.5, which is 9. No, I know. Yeah.
Uh-huh.
And then you add them together, which gives you 13.
I hope so. B. Estimate.
So could you do 2 times 5.5, then half it,
Yeah.
which is 5.5.
There you go.
And then you do 2 times 1.5.
Yeah.
And then add 5.5. And then you need to round it. Would you round it up?
Okay.
So it'd be so wait. 2 times 1.5 is 3. And then you'd add it to give you 8.5.
And so roughly
9.9.
roughly 9 girls. Do I have the answer? Is this the right one? Question 4A. Question 4 looks okay. 58 girls. What are we missing? There's some constant. Oh God, no. See, histograms, man.
Multiply everything by 2, I think. That answer you got, so it'd be...
No. Well, that's one way you can do it, but it's basically... Yeah, you have to... They multiply everything by 2k plus 4 times... Wait, 1.5, 5.5... 1.5... Oh, so just put them all together. You basically have to find the total area of everything.
Yep.
So they just did 2 times, so these ones, 1 plus 1.5. So just a quick way of finding the ones that all have the same.
Yeah.
4.5. So what is that? 2.5, 7, 8, 9, 10, 11, 12.5. So that's 25. And then the area of the last one was 4. And so the total area of everything is 29. And so 29 times something gives you 58 girls.
Okay.
And so what is that?
You divide by 29 on both sides.
Mm-hmm.
Which gives you 2.
That's it. So the total number of girls is 58. The total area is 29. And so basically the area on the paper is like half of the total frequency. And so you'd have to double it.
Yeah.
So would these be doubled then? 26 and 18? Is it that simple? 26, and they rounded it to 17. Yeah, we'd have to, if we were to double, that's 16. Yeah, double that is, double the unrounded one would give 17. Yeah. Okay. So that's what we have to watch out for. Yep. Okay. Question A.
Okay. One reason for it is because it has like grouped data.
Yeah, do you remember the second one?
And it's co-continuous.
That's it. Okay, second one.
So for this, would you do 8.5 minus 7.5?
Okay.
Which gives you 1.
Okay. What's next?
Then would you do 1 divided by 8?
So this 4 to 6 one was for 10 students.
Yeah.
So that represents 10 students.
Yeah.
Let's see. And its height was 2.5. So what is the area for this one?
2.5 times 2, which is 5.
And so 5 centimeters squared represents 10 students.
Okay.
And so how do we go about the next one?
So would you do the height of 8, so you do 8.5 times 1, which is 8.5.
No. So it is like that. 8.5. So this one had 10 students.
This one has, we don't know.
Yes, you do.
Oh, right, it's 8.
Yeah. And it has a width of 1.
So you do,
No. Sorry. This one has a class width of 2, but a width of 1. So this one has a class width of 1.
and a width of 2.
I believe other way around.
So it's 2 for the width, 1 for the width.
So this one, the class width is 2. The actual width is 1 centimeter. So this one here, the class width is 1.
And the width is 2. A half.
Yes. And the actual width is a half a centimeter. The width is half a centimeter. We need the height.
So you do half times 8.
No. How do you
1
get,
times 8.
how do you get the height of...
Oh wait, you need the height.
Base times height is area. So height.
Base divided by class width.
Base times height is area. Make height the subject.
So you divide by h on both sides. I divide by base on both sides, so area over base.
Mm-hmm.
So it'd be 8 divided by 1.
We want the height in centimeters.
Oh, so you square root 8.
No. 8 divided by a half.
Okay. Isn't that just 8 times 2?
Yeah.
Which is 16.
So I believe that should be 16. Do I have answer? Height is 4. The width is 0.5. The height is 4 centimeters. The bird took between 4 and 6 to respond as of width 1 and height 2.5. This stuff. Histograms. I'm not crazy. It's the mixture of the actual data and the
Yeah.
drawn data. Let's see. Make this a bit smaller. Question B. Okay, so we have our bar. So it is from 4 to 6.
Yep.
We're told it has a width of 1 centimeter. We know its class width is 2. We're told its height is 2.5 centimeters. Okay, so what is the actual area for this one?
1 times 2.5.
Yep.
Which gives you 2.5.
And so 2.5 times something has to give us 10.
Okay.
So
Would it be 4?
So that's it. So K is 4. So now we do the same for the other one. 7.5, 8.5. We know the class width is actually 1. What else do we know? We know the number of people is 8.
Yeah.
We said that this was a half.
Yeah.
If the actual number of people is 8, then what would be the area for this one?
So the actual number of people is 8, but the area is the people, isn't it?
Yes, but it's how it's represented. So on this one, an area of 2.5 centimeters squared represents 10 people.
Okay.
And so what area would represent 8 people?
So would you need to do like a half times 8?
No. It would be a half. So it's basically area times something equals frequency.
Okay.
Area times constant of proportionality equals frequency. We're told the area, well, we don't know the area. Am I getting the same thing? How did I do? Nope, doesn't work. We just found out that K is 4.
Yep.
And we know the frequency is 8 people.
So you can divide by 4 on both sides.
Yeah.
Which gives you 2.
And so the area is 2 centimeters squared and the width is a half. Oh, they wanted the height. Okay, so what would be the height?
So would you do 2 divided by a half?
Yep.
Which gives you 4.
Yeah. All right. I think so. AK equals frequency area of the in centimeters squared times the constant of proportionality gives you the frequency.
Yeah.
And it helps to have this diagram. Let's see. That's okay. So this is pretty common where they give you half of one, half the other, and you have to do that. But I think you're going to be okay with these ones.
Yeah.
Hang on. I think you're fine with these ones. Okay, this is the one.
So the class boundaries just be 13, but it wouldn't be 13 to 14. It would be the midpoint of 12 and 13.
No, this is rounded data.
Okay. So would it be 12.5 to 14.5?
Correct. So that's 12.5. Because a histogram doesn't have gaps. It's continuous data. Okay, let's try part B.
So we know that 18 is the width.
How did you get the frequency? Frequency is proportional to area. So area times constant of proportionality gives you frequency.
The frequency is 18.
So the frequency is 18. So this one has a width of 4 and a height of 6.
Okay. So it has a width of 8.
Width of 4, height of 6. So what's the area?
24.
It's 24. And so it's basically 24k gives you 18.
So you divide by 24 on both sides.
Mm-hmm.
Which is a quarter. Oh no, 3/4, which is 0.75.
Okay. So now we use that. How do we use that?
Okay. So would you write down, would you draw a box for 15 to 17?
Okay. And so what do I need to draw on?
You need to draw 18 in the middle for the frequency.
Let's see. 15 to 17. So the frequency, I'll just do frequency as 18. Oh, hang on. This was the 13 to 14 class.
Yeah.
So that was 24. No. Sorry. We're mixing them up. They're both 24. Is that right?
Okay.
So that's a frequency of 24. And then this one had a width of 4 and a height of 6. So an area of 24. All right. So it's exactly the same.
Yeah.
And so this one really is just 18 and 18 centimeters squared.
18 add 18.
No, 18 and 18 centimeters squared. That's
Oh,
exactly.
so it's 18 times 18.
No. K is 1. They're just directly exactly the same thing.
Oh, right, okay, yeah.
24.
Would the width be 2?
You might think that. Let's compare the previous one. What is the class width for the previous one?
Well, it's only got 1, so, and it's 4, so for the second one, would it be double 1, which is 8?
You have to unround it, because when you draw this, you will expand the bars to fill the gaps.
Okay, so it'd be 12.5 to 14.5,
Yeah.
which would give you 1.
No. 14.5 take away 12.5.
2.
So the class width is 2. So class width of 2 is the same as a real, like a bar width of 4 centimeters. We want to know the bar width for this one.
So would it be from 14.5 to 18.5?
Well done. 17.5.
Oh, yeah. Which is 3.
So the class width is 3. And so the bar width?
Bar width is double that.
Yep.
6.
So that should be 6 centimeters. Okay. And now we need the height.
Okay. So would you do 18 divided by 6,
I believe so.
which is 3?
So that seems a bit too easy because K was 1. That's 3. That's 6. Okay, so just K was just 1. Yep.
Yep.
Okay, we're getting there. Interpolation. Heavier than 10. This is similar to what we did before. I'll just mention it. It's a simplified version for histograms. Where is this? So this, what is the upper bound, lower bound for that group?
Lower bound would be 8.5, upper bound would be 10.5.
Yeah. And so let's say this bit here, from 10 to 10.5, what fraction of that group is that?
Is that a third?
So you've got, now it's going up in,
Oh, it's a quarter.
yeah. And so you would just find a quarter of those people.
Yeah.
And that's how you go about interpolation for that. It's an easier interpolation than what you've done before. Okay, large data set. Right, let's try it.
So would you do 12 minus 11?
Yeah, we don't need to
Which
unround
gives
this
you
one.
1.
Yeah. And so let's see. So which width is that?
Is that the class width?
So that one's the class width. So class width, sorry, it's not 1 centimeter, it's just 1. Yeah, like 1 degree.
Yeah.
Alright, 1 degree. So you can use the one before it.
It says that a width is 1 centimeter for 8 to 10.
Okay, so what's the class width and then what's the bar width?
So it's 2 for the class width and 1 for the bar width.
Yeah. And so this
So
one,
it would be a class width of 1 and a bar width of a half.
yeah, that's a half a centimeter, 0.5 centimeters.
Yeah.
Find the width. Okay, and they want height as well.
Height would be frequency divided by bar width.
Let me see. There might be some constant. So what is the... So AK is equal to frequency. So for the one before it, what is the area? What is the frequency?
Area is A.
Like, what is the area? Width of 1, height of 8.
Oh, so it'd be 8.
And this is the 8 to 10 group. Oh, so it's similar. Oh, okay. So K is 1. All right.
Yeah.
And so the height then for this other one?
Would you use AK equals frequency again?
Yeah, but K is 1, so it's just a frequency of
Oh.
8 is an area of 8.
So would it be 7 divided by a half?
Yep.
Which is 14.
So the height is 14 centimeters. Mean standard deviation, all the stuff you've done before with these things.
Yep.
14 and a half. Okay. Okay, histograms.
Probably a half.
So I think we got there in the end. The
Yeah.
end. Okay, comparing data. We did this a lot already. I don't know why they have it now. Oh, they have it now for standard deviation and mean. We've done it for range and interquartile range.
Yeah.
Compare the average. Compare the spread.
Okay.
The average, well, let's match them up. What you have before is the interquartile range and the median. So
Okay.
the median average and the interquartile range spread. Or this way would be the mean average and the standard deviation.
Okay.
Yeah, and you would do that. I suppose you could use variance, but I think they'll use standard deviation. Calculate the mean and standard deviation. Let me just cheat day. Okay, whoops. Oh, yeah, I don't even have the answer. No, I do. Okay, part A gives us the mean and standard deviation for the first group.
Yeah.
For Heathrow, and then Leeming we have this different stuff. Compare the two. In the context of the question, daily mean temperature.
Okay. So we're comparing Heathrow and Leeming.
Yep. Compare the daily mean temperature in Heathrow with Leeming.
Okay, so we want the mean for Heathrow, which is 5.62.
Yep.
No, 562.
Hang on. Heathrow, the mean was this one. It's like 562 over
Oh yeah, divided by, yeah.
the
There's
days.
18.1.
Yeah.
So the mean temperature was higher in Heathrow than in Leeming.
So yeah, on average, yeah, Heathrow is warmer, has a higher daily mean temperature. Okay.
And then you could say that the standard deviation is higher in Leeming than in Heathrow.
And what's the significance of that? Like if the mean is higher in Heathrow than the other, then that means Heathrow is hotter.
Yeah.
What is the significance of the standard deviation being bigger?
if more of it's been like doubled, it's higher than like the other if it goes up.
Nope. The temperature is more spread out.
Okay.
So you have days that are much hotter than the average. You also have days that are much colder than the average. So they might average out into the middle, but that's, they are more spread out. Whereas if you go to a southerly place like Leeming, the variation in temperature isn't as much. It's kind of just the same. It's just warm. Never very cold, never very hot. The mean daily temperature in Leeming is lower than in Heathrow, and the spread of temperatures is greater in Heathrow. Yeah, compared to the mean and standard deviation. Box plots. What is this here? That's all right. Let me move this to box plot. Just want to make sure.
Yeah.
Yep, I think that is it. Median and quartiles for both samples, and then compare the two. So I'm gonna put that with median and interquartile range stuff.
Yeah.
Because we did. I'll tell you what. We'll do one. All right. So Lukers and Camborne. Compare the two. This is daily mean wind speed.
Okay. What do the two X's mean again?
Outliers.
Okay.
So they've been removed.
Would it be Camborne?
Like what about Camborne?
Actually, what are the outliers? They've been removed because of. Is there a reason they've been removed, right?
They were more than 1.5 times the interquartile range, bigger than the upper quartile. So they're just considered like a freak thing. Like maybe this was a hurricane. You know what I mean? It's not really.
So then Lucas then.
Like, what do you mean, Lucas? Like, compare the two.
Yeah. Well, yeah, it would be better to go to. They should go to Lucas because.
Yeah. What?
Because it has less spread. Is that right?
What are you comparing? What are you looking at when you say spread?
Lucas and Camborne. For question 3A.
Yeah. Like, how does it have less spread?
Because there's less space between the ranges.
The whiskers, is it?
Yeah, the whiskers, yeah.
Instead, a better measure of spread is the interquartile range.
Okay. I think Lucas is less. Yeah, it's less by like one box. Wait, no, I think Camborne is less spread.
Okay. And so let's start with average. Which is windier?
Camborne.
Yep. Is that, how do you know that?
Because the average is higher than it shows on the graph, that the middle line is higher than the one in Lucas.
Yep. So Camborne on average has a higher daily mean wind speed.
Yeah.
And let's see. So we should go with Lukers. And Lukers is more consistently has less variation in its wind speed. Is that right?
Yeah.
Yeah, that's good. Okay. I'm happy. Let's see. Compare the lengths. See, do I just move all the similars up? See, this should be with this. No, I'll just move all of the similar stuff back to all together.
Okay.
How would you find the median?
You divide 40 by 2 and then find the middle on the graph.
They go above 40.
That was 50.
Yeah.
So you divide 50 by 2, which is 25, then look across the graph.
Okay. And so compare the averages.
You could say that males is higher because they have the median is in higher length when it goes down. Yeah.
Yeah, on average, males are longer than the females, and then you could do the same with the interquartile range, or let's say let's say even just the range. They think the range is the same.
Yeah.
Cumulative frequency, greater spread. State which type of rat has the greater spread of masses. Able to tell that by looking at it.
Was it the black rats?
Yeah, they've got 2 instead of just 1 there, and they've got 6. Yeah. So they're more spread out. I think that's okay. Okay, comparing data.
Probably between a tick and a half.
So I think that's chapter 3. Yep, that is chapter 3. Let's see. So histograms are the tricky one.
Yeah.
We can practice more histograms, or we can just move on. Do you have any preference?
Do you reckon we could like practice them after we finished and like doing all the topics, then go back to the hard ones?
Yeah, that's what I was gonna do anyway.
Yeah.
But yeah, okay. So I'll go for chapter 4 then. See how we do. So yeah, I was gonna like revise like every few lessons, but then I thought let's just get through it and then revise at the end.
Yeah.
Because you end up revising stuff anyway. Chapter 4, correlation. Correlation. Where'd you hear that word?
Say if there was a positive or negative correlation or no correlation on the graph.
Correct. That looks familiar. GCSE. What they do is you draw a line of best fit, like you kind of estimate a line of best fit.
Yeah. Yeah.
Go up, hit the line, all that stuff. Well, for A level, you will find the equation of the line of best fit. So it might be actually like y equals 3x plus 2. And they will say, estimate if someone's breath is 25 breaths per minute. Instead of going up, hit the line, go across, you would do 3 times 25.
Yeah.
You know. Let's see. X is explanatory variable. Y is response variable. X is independent. Y is dependent.
Okay.
Correlation. And there's also a correlation coefficient that they'll go through. So you might notice, let's say the last two. These, if you drew a line of best fit, they're all kind of close to the line. Whereas this one, they're much closer to the line.
Yeah.
And so correlation coefficient for that one is close to 1. For this one, it will be further away from 1.
Yeah.
This one will be closer to 0. This one that down here might be like close to -1.
Yeah.
And then this one will be this will be greater than -1. That's 1. That's less than 1.
Yeah.
So we'll get there. Okay. You know how to draw a scatter diagram?
I believe so, yeah.
And that's what it looks like. Okay, describe the correlation.
So weak negative correlation.
Great. Weak negative correlation. And in the context of the question, so interpret that for part C.
What do you mean by interpret? Like put it into the answer of like the population density?
Like in the context of the question. Yeah, population density type of stuff.
So you could say as the distance goes up, there's less population density.
Yeah, so you could say, yeah, as x increases, y increases is positive correlation. Decreases is negative correlation.
Yeah.
And you have to don't say X and Y, like it's been the context of the question. And so as distance from the city center in kilometers increases, the population density in people per hectare decreases.
Yeah.
As distance from the city center increases, the population density decreases. Yep. Two variables have a causal relationship if a change in one variable causes a change in the other. But with correlation, they're not necessarily one causing the other. It might just be, there might be some kind of connection, but could be the other way around. One could be causing the other, Okay, describe the correlation.
It looks like 0.
Maybe it's slightly negative, is it? I don't know.
Very slightly.
Age at which education or training ended and hourly pay. Maybe it's 0.
Yeah.
Okay, question B. Maybe slightly negative.
Yeah. Well, but it never stated like a conclusion.
So Hideko is saying basically you earn less, your earnings are going down the older you are when you leave education. A reason why that might not be valid.
Well, because people can have good jobs and get paid more.
So you'd expect it to be the opposite. I think it's because Hideko's data is only from the ages of 16 to 23. And so from 16 to 23, that's true. Like, obviously you get paid less if you're not working, if you're in education.
Yeah.
And if you left school at 16, you're right away, you'll get paid more than someone who's still in school who's not working.
Yeah.
But if you were to extend this data past 23, you might see a different trend. It's like they're doing a thing called extrapolating. So it's like outside the data. Let's see. Respondents who left educating later would have significantly less work experience than those who left earlier. This could be the cause of their reduced income shown in her results. And they used a small sample. Okay, that was weak negative correlation. All right. Okay, let's take a look at this. Yeah, outlier. Yeah, we're okay for outliers. 1.5 times interquartile range. Include, exclude. Describe the correlation. Maybe I'll just show you.
Okay.
I'm going to use simple calculator.
Okay.
Oops. Simple calculator menu. Statistics is 6, I think. And this is y is equal to a plus bx. It's a bit like mx plus c, but for the line of best fit.
Yeah.
A plus bx. Okay. So put in x, which is 0, 6.8, etc.
Okay. Wait, is it y equals a plus bx?
Yeah.
Okay.
0. Frequency can just be 1 for everything. Let's make sure I'm not covering anything. Yeah.
And then do I click option?
So I think it's option. Two variable. No. Let's try regression calculation. 4.
Okay.
The correlation is regression, which is R, the last one.
So it's minus 0.29.
And so what might you say about that?
There's more rainfall than less rainfall than sunshine.
Correlation?
It's negative.
Yeah, maybe weak negative. If it was minus,
Weak negative.
like -1 would be like perfect negative. Minus 0.9, maybe strong negative. That's like weak negative. I'll just mention the other two, A and B. Like B is the gradient, A is the intercept. So it's like mx plus c, y equals a plus bx. That's of the line of best fit.
Yeah.
And so you can get the line of best fit like that. Do you think there is a causal relationship between the amount of rain and the hours of sunshine?
Yeah, it could be raining one day, and it could be really sunny the other.
Like on the same day?
Yeah.
Yeah, I think it's probably one isn't causing the other. They're just both connected to clouds. So the cloudier it is, the more rain, and the cloudier it is, the less sunshine.
Yeah.
And that's why you're getting that kind of weak negative stuff. All right, that's section 1 of correlation. What do you give yourself?
Tick.
Hey, we got through it. How was that for you, Adam?
That was great.
And so continue this next time.
Yes.
And any questions from you in general?
Do you want me to ask my mum now about the date?
No, you can ask her and you can email me or tell me next time. It's all right.
Okay, that's yeah.
I think I'm okay because we're now on to chapter 4. Let me just take a look. Not pure 1, stats 1. Stats 1. My only thing that I would really, really like is the only thing that I like is the revision. That's what I want to.
Yeah.
Okay, so we're on chapter 4, and there's a total of 11 chapters. And so yeah, once we finish chapter 11, then it's just revision.
Yeah.
And I have some ideas for that. Yeah, so I think we're okay.
Yeah.
But the exact date in the thing would help. Anything else?
No.
All right, well done, Adam. You did great.
Thank you.
I look forward to trying again next time.
You too. Bye.
Cheers. Take care. Goodbye.